and welcome to the results video for round 2 of the Cambridge Biology Challenge 2024 to 2025. This month's question was pick an aspect of winter or Christmas and discuss it from a biological perspective. Normally, we begin these awards video with a mini lecture, and we highlight some of the big salient points which we were expecting you to cover. But this time, we don't really feel we can. In fact, you've shown us nationally just how incredibly diverse are the number of different ways in which this question could be approached. Whether you decided to look at the biochemistry of Christmas dinner, whether you decided to look at the pathology of seasonal affective disorder, whether you looked at the science behind reindeers flying or snowmen moving, we were blown away by how many different angles you used to tackle this question. So for that reason, we're just going to skip straight to the entries here and so celebrate some of the best responses we had. But as always, with over 700 submissions, it was an incredibly difficult task to pick just 10 award winners. We did have quite a lot of runners-up in categories this time as well. So even if your team isn't featured on this video, don't despair. You could still well have picked up some great points and prizes. Okay, well, let's get started. The first category we're going to look at is the best essay category. And I think perhaps something of a first here. For the first time ever, we think we've had the same person win the same category 2 challenges in a row. A huge congratulations to Mustafa's team from Manchester for yet another fantastic essay. I hope this shows you we don't change which team wins each time to sort of spread the rewards. We really are trying to kind of reward the very best biologists out there. So when you do win the award, you should be really proud. We're only judging you on the basis of what you submit. And Mustafa from Manchester, like a lot of you, he decided to talk about seasonal affective disorder. So the fact that many people report lower levels of life satisfaction and general happiness in the winter months. But unlike almost everyone else, Mustafa took an evolutionary perspective. He said, look, I wonder what, if anything, the possible adaptive benefits of seasonal affective disorder might have been in the past. And in his essay, he engages with multiple peer-reviewed studies which make suggestions. So, for example, perhaps actually it makes sense to evolve lower levels of activity and lower levels of energy consumption during winter months when resources are scarce. Now, we're hoping to share all of these round 2 and round 1 winners with you at some point this year on the website, and when this does go up, I'd highly recommend giving Mustafa's essay a read. Well done. Okay, next category is best poster. We were really torn here, so many amazing posters. In the past, our best poster awards have generally gone to posters which sort of excel because they're very aesthetic or they're very beautifully produced. But this winner did something quite different. Wow, what's this? Well, this is one of the first times, I think, we've seen a properly formatted scientific poster submitted. What's a scientific poster? Well, at conferences, when scientists gather to present their work, conferences often include poster presentations in which you will create a scientific poster which outlines your aims, your results, and your conclusions, and you will print that poster out and you'll display it during the conference. And this poster here was so impressively done that we wouldn't have blinked had we have seen it at a real conference. Incredibly impressive. Well, let's give credit to the team. So this was Sophie Squared and Zoe Squared. That's their team name. And what were they looking at? Well, they were interested in testing 2 hypotheses. Working with beetroot as an example of a plant species which might, you think, be vulnerable to freezing, they first of all measured how the rate of ice crystal formation in beetroot cells changed at different temperatures. But then the really interesting work, lots of you talked about antifreeze mechanisms and how organisms can resist freezing. While Sophie squared and Zoe squared, what did they do? They added a cryoprotectant. In other words, they tested whether that fact that a lot of you mentioned, a lot of you told us that glucose, that organisms like the wood frog can add high levels of glucose to their cells in winter to prevent freezing. Well, Sophie and Zoe tested whether glucose really does act as an antifreeze molecule, and they showed that that's exactly what happened. In their results table, they outline how adding glucose effectively lowers the freezing point. Very impressive. Well done. Next, on to best presentation. Again, a very different sort of presentation winning this time. Almost 100 slides long. And you might be thinking, well, how on earth did that stay within the word limit? Well, this presentation was very long because it was very different. This presentation was a game-like presentation, a sort of pick your own path style adventure, in which you were an animal about to go into hibernation or torpor during the winter, and you have to make decisions. Decisions about when to rest and when to forage. And as you progress through the presentation and as you click and make decisions, you can see your energy levels change. And at the end of the presentation, depending on the items you selected, you can see whether or not you survived. Many animals don't survive hibernation. We were really impressed by the level of biological thought and insight that had gone into this entry. So very well done to Judy from Carmarthenshire for this really engaging presentation. Next, best video. As always, lots of incredible videos, but we do think there was one clear winner here. So very well done to Alice from Manchester for her wonderful discussion of the wood frog. Now, lots of you talked about the wood frog and how incredibly the entire animal can effectively freeze. You have this extra cellular ice forming all over and inside the wood frog. And lots of you sort of talked about the physiology behind how this animal can cope with freezing and thawing. But what Alice did, which really set her video apart and really made her explanation incredibly clear, was that she created her own plasticine models, which showed the wood frog's physiology before freezing in the summer on the left here, and then after freezing in the winter on the right here. Again, really, really impressive, really high quality video, and we learned a lot watching it. Next, best audio. We got lots of podcasts this time around, far more than usual, so it was a difficult winner to select, but there has to be one winner. This team looked at the biology of elves. One of the only teams, there were one or two more, but one of very few to look at this topic. So really well done to Beyond the Microscope from Bournemouth for their podcast in which they explored the biological plausibility of elves. What do I mean by that? Well, let me give you some examples. They made points like this. They said, well, look, elves are very small. What do we know about small animals? What challenges do they face? Well, they have a high surface area to volume ratio, and therefore probably a high level of heat loss. Hence, what could they do to cope with this? Well, like many small animals who live in wintry climates, if they're not going to move, they'll need probably a thick layer of fat or fur. Many more interesting elven discussion points made in that podcast, and another one we're looking forward to posting at some point so you can all listen to it. All right, next, the best researched. Well, this was another difficult entry, but something quite different this time. So really well done to Bella from Kent, who used a very systematic approach to research the nutritional components of a classic Christmas dinner. Again, the images here don't really do her work justice, but Bella went through and systematically tested for all the various components of a Christmas dinner using things like Benedict's test, the Biuret test, and the iodine test, systematically tested for the presence or the detectable presence of different biomolecules. Very impressive write-up with some surprising results. So really, really impressed. Next, clearest explanation. Well, we absolutely loved this group's video. This group, like many of you, looked at Rudolph. And this group, like many of you, looked at how Rudolph might be able to fly. But I think they were the only group who looked at buoyancy as a potential solution. So they did some really interesting calculations, which considered whether maybe reindeers are able to fly in the same way that fish can regulate their vertical depth. Fish use a swim bladder, a gas-filled organ, to control their buoyancy. And this team here from London, Kushali and Hannah, did some fascinating work to try and think about, well, how much helium, for example, or some sort of gas less dense than air, how much helium would they have to store within them for this to work? And they went on to look at the use of bioluminescence and then the sort of the cardiology of the reindeer. Really, really impressive and very, very clear drawings and clearly worked reasoning. So well done. Okay, next, always a very tough one, and best biological facts. We always get so many great facts. That's why we give out so many badges of merit. But there has to be one winner. And this round, we selected Jaya's team from London as the winner of the Best Biological Facts prize. Have a look at that image on the screen. What does it look like to you on the image? Well done if you thought hair. This, interestingly, is the hair of a polar bear. And this team taught us several things about polar bears and their coloration, which, to be completely honest, none of us had ever come across before. We learnt from Jaya's team that polar bear hairs are actually not white. They contain no white pigment at all. The bears spend no energy creating white pigment because it's not there. Instead, the hairs are hollow and translucent. What's going on? Well, the hairs are translucent, and that means that as light enters them, but gets scattered inside, sort of backscattering inside because the hair is hollow, that the combined effect of this produces the image that they are white, even though there's no white pigment. The hollow hairs also provide another opportunity for insulation. We learn even further from these guys that the skin of polar bears is black. This makes sense as they explain that. They say, well, look, you want to be, if you're a polar bear, you want to have the skin color, which will be maximally adapted to absorbing heat. And we all know that black is the best color to absorb radiation. So they've got the best of both worlds. They've got white looking hair on the outside to camouflage, but then when it comes to actually absorbing the heat through their skin, they've got black skin. Amazing video, amazing facts. Really impressed, and thanks for sharing them with us. All right, next up, the most original. Always so difficult. We had so many good flip books and websites and even some video games that were made. But on this occasion, for most original, it's gone to this team here. So if you recognize this logo, then you must be the Diplodocus from London. This team must have spent hours on their submission, and we don't encourage to spend hours and hours, but in this case, it was time well spent. What did they do? Well, they created their own board game. And the board game wasn't just a bit of fun. The board game was absolutely packed with interesting biological facts and questions. So in this game, as you move around and try and consume different portions of Christmas dinner, it seems KFC is a component of their Christmas dinner, but you learn both biological facts about the food and then have to answer questions to progress. They had over 6 pages of these cards. Loads of cards, loads of effort gone into this. A wonderful game. We haven't played it yet, but we're definitely going to give it a go. Okay, next up, most entertaining. Well, very well done to Isabella and Tara. And you'll note here that in their sort of album cover, if you like, that Lana Del Rey apparently appears in their video, and she did. They obviously managed to get her to do a cameo for them, or perhaps there was some other mechanism used. In this presentation, the girls, alongside, keeping us entertained and producing some really funny videos, they also communicated some fantastic information about the biology of reindeer. Our particular favourite was this. They pointed out how Rather than sort of thinking of reindeer like some Bambi-style creature, all helpless and skittish when young, reindeer in reality, well, 19 minutes after birth, they can already run faster than an Olympic sprinter. Wow. They can run at 50 miles an hour for up to 13 miles a day when migrating. That's only slightly slower than the top speed of the second fastest land mammal. It's absolutely incredible. Um, and so Teller and Barrow, as their team name is called, from Cardiff. Big congratulations from us. Really entertaining video. Another one that we'd love to share with you all. All right then. So now the moment you've all been waiting for. There were over 700 entries, but there can only be one overall winner of round two. It's always difficult. But there was one entry in this round which approached the question from such a different angle that at first we thought it wasn't even relevant. And I think the judges who sent me feedback on this entry, they were really shocked at first by the title. But after thinking about it and discussing it, we decided it absolutely falls under the question, and the content was amazing. Have a look at this. So they were the only team to think about Valentine's Day. Well, 14th of February, it is in winter. It doesn't fit under the category of what we normally think about when we think about the biology of Christmas events. And they made some really interesting points. They were trying to explain why Valentine's Day might be held in winter. And yes, you've got the historical explanation about St. Valentine, but they made the following biological points. They presented data like this. So this data here plots changes in human relationship formation in green and breakdown in red. And you can see from this graph that relationship formation peaks in winter and that breakups peak in April. That's interesting, seeing that actually almost naturally in humans, we seem to be forming lots and lots of new relationships in winter, the same time of the year that Valentine's Day is. Why might that be? Well, this group went on to actually sort of discuss the hormonal biology of this phenomenon, discussing how actually changes in serotonin and testosterone levels throughout the year have almost set us up to be more interested in romantic relationships in the winter. And they cite some really interesting data which shows that 80% of heterosexual men actually sort of say they will find their partners more attractive during the cold months. So a really interesting and completely novel take on this question. So very well done from us to Lakshmi and Samavi for this wonderful, wonderful entry, and a huge congratulations from us for being the winners out of over 700 entries nationwide. Well done, and we're looking forward to seeing your entries for round three.